So a 300 watt heat pump operates between the ground, whose temperature is 0 degrees Celsius, and the interior of a house at 22 degrees Celsius. What is the maximum amount of heat per hour that the heat pump can supply to the house? Okay, so what does a heat pump do? So this is the house, let's say. You're maintaining 22 degrees Celsius. It's cold outside. And you're going to draw heat from the ground and dump it here. The ground is at 0 degrees Celsius. You're drawing heat from a colder region and dumping it in the warmer house, just like a refrigerator. Okay, by the way, so do you guys know what is the, in Florida you can have heat pumps. Do you know what is the average temperature of, in Florida, year-round average temperature? Huh?
Like in the 70s or 80s?
It's 72 degrees Fahrenheit. Okay. Here's how you find the average temperature at any place. Dig a hole 3 feet deep, and the temperature there is the average temperature. And the spring waters here are at 72 degrees. So that's the average temperature. Okay. All right. So what's the heat pump going to do? Oops. So there's the ground. It's going to absorb heat from the ground, which is at a lower temperature. So here's your heat pump. Of course, you have to do work to do this. And then it's going to dump this heat into your house, which is the warmer reservoir. Okay. So QH, the amount of heat it's dumping into your house, is the amount it absorbed from the ground plus the work you did that got converted to heat, and that's also dumped into the house. Okay. All right. So a 300 watt heat pump. Okay. So QH by T, the amount of heat dumped into your house per second, is the amount of heat absorbed from the ground per second plus the work done by you per second. And the work done by the heat pump per second is given by that, 300 watts. So it's a 300 watt heat pump. Okay. So this guy is 300 watts. They say, what is the maximum amount of heat per hour that the heat pump can supply? What is the best heat pump out there? I'm sorry? Oh, well, yeah, but theoretically, the theoretical maximum is a Carnot heat pump. Okay. So for a Carnot heat pump, QC is W. This is QC divided by QH minus QC, and COP max, the theoretical upper limit, is a Carnot heat pump. And for a Carnot heat pump, this is the maximum performance. These guys, a Carnot heat pump is given, COP is given by the operating temperatures. Okay, it depends only on the operating temperatures. Okay, so in our case, the operating temperatures are TC is 273 Kelvin, TH is 295 Kelvin, and 273 Kelvin. Okay, they're all in Kelvins. So COP is 273 divided by 22. Whoa. This is crazy. Find best performance of heat pump. Now COP depends on where you're operating, but anyway. Okay, so we have this. So COP max is that. So the maximum amount of heat you can remove is W times COP max, and the rate at which you can remove heat is, so this is 300 watts times 12.4. (3,200 watts). So QH, the rate at which you can dump heat in the house, is QC by T plus W by T. So the rate at which you can dump is 372 plus 300 watts, 4,020 watts. Okay, and what they want you to find is the amount of heat you'll dump in 1 hour. And 1 hour is 3,600 seconds. So that's how much heat you can dump into the house per hour. Yep.
COP is around 4.5.
Okay. All right. So that makes sense. The max for a car, no, it's 12. Because it for a refrigerator in the market you had a 12 COP, right? And so I guess heat pumps, there's different. Okay.